All right. So for the workup today, measures of spread. Measures of spread is also called measures of dispersion. And it simply explains how far apart or close the samples in a population are. And it includes range, standard deviation, and variance. So remember when I talked about mean and median, and then the interquartile range for the median and standard deviation for the mean, telling you that the standard deviation gives you the measure of spread for the entire population, and then the interquartile range gives you the spread around the 50th percentile. Okay, so I gave an example and said that I will come back to it, and I think I want to now text right down here. So let's say you have data 2 plus, where's my plus sign? Plus 3 plus 6 plus 4 plus 5, and it gives us 20 over 4, which is equal to 5. And then the next one is 0 plus 1 plus plus 4 plus 5 plus 10, is equal to 20 over 4, which is equal to 5. Now, what I want to show you is that if you look at this, the first set of numbers in a number line, you can see that they're kind of packed together. And then the second set of number in the number line, the 10 kind of makes it farther apart. Sorry for that. Farther apart from the rest of the variables. So you can see that all of them here that's the mean 5. The second set of numbers, the mean is also 5. Now what I'm trying to say is that to get the spread of this data, we're going to kind of use the range. Like range is highest number minus lowest number, and here it's 5. The highest number here is 6, and the lowest number here is 2. So 6 minus 2 is 4. So range equal to 4. The other one, range, the highest number 10, and the lowest number 0 to 10. So this range kind of gives you an idea of the spread of this data, how from one point to another, and then basically what I'm trying to convey, that it is good that when you're reporting your papers, you kind of report the range too, so that the reader kind of have a mental picture of the spread of your data. The spread of your data, are they tightly packed or they are loosely packed? Let's take, for instance, now the mean income of persons in let's just say Nigeria is 45,000 naira. I don't know why I like 45,000 naira, but 45,000 naira. And then you just say the mean income is 45,000 naira. So now what we have in mind is that we don't know whether that's data, that distribution was from a normal distribution, that's a quotient curve, or from a skewed data. What do I mean? Let's say the likes of, we take samples, and then there are the likes of Dangote, Otedola, President Buhari, the top politicians, and then on the distribution. So these rich persons, these rich politicians, these rich businessmen who kind of drag this mean to themselves. If they drag this mean to themselves, it will give you a higher mean income. You get, it's going to give you a higher mean income, showing you a false representation of the mean income. That means if you don't report the spread of your data, like if you don't report the minimum or the maximum, that's the range of the data, your reader cannot have a mental picture. If it says, okay, this is just the mean, you say, okay, yeah, this is the mean income. But if you kind of report the range of your data, if you kind of report the range of your data, it gives the reader an idea that, okay, yes, this is from two balanced, like the distribution is balanced, and the sample was not collected from, did not favor one part of the population, like the example I gave, which is the rich persons. So the rich persons drags this mean, pulls it to their side, and gives it a false representation of the mean income of the country. So now, I think I'm done annotating. Okay, so these are just let's see my screen. No, I'm trying on my screen. Okay, so measures of spread. So this, the measure of spread kinds of give you an information on how, like I said, far apart or close the distribution it, and give the reader an idea of the true representation of the samples in the population. So the range is the highest number minus the lowest number, which I have already talked about. Then the standard deviation is a measure of spread of values around the mean. And then the variance is the square of the standard deviation. We usually use standard deviation with the mean in a parametric data, and the parametric data is a normally distributed data. So once you use the standard deviation kind of gives it, okay, let's say you want to find the mean age, and you see that the mean age is 27 in the population, with your standard deviation of, your standard deviation of 3. So what it's basically saying is that the mean we got is the best estimate, the best mean age we can get. But then there is the spread of the data, that's the spread of the age, could be 27 minus 3 lower, or 27 plus 3 higher. So that is the spread of the data. So once you're reading your papers and you see mean plus or minus standard deviation for a variable, you know that it is indirectly telling you the spread of that variable. So that is the standard deviation, and the variance is just simply the square of the standard deviation. Okay. Can you move, please, 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 please? Here. Okay, so this is the formula for standard deviation. This is the population standard. That's to calculate the population standard deviation. Summation of each value from the population minus the population mean, all squared, all over the size of the population, and then you take the square root. Let me see if I can annotate. Let's see. Okay. Your 5 plus 2, 5 plus 2 plus 7 plus 3 plus 1. This is equal to 5 plus 2, 7, 7 plus 3, 10, 10 plus 1, 11. So this is your mu, that's your population mean. So now to get the xi, which is each value from the population, you say 5 minus 11, which is minus 6, I guess. I'm not sure, my math is not that. 2 minus 11, which is equal to 2, 4, 5, 6, that's minus 9. Minus 9. And then that's how you, when you're done with this, you kind of follow the formula. And this is, you square it. So minus 6 all squared give you 36. Then minus 9 all squared give you 81. And so once you're done, you add everything up. Then you subtract it from your population mean. You divide it by the number of the size of the population, which is 4. You get your answer and you take the square root. So that is simply the thank you. Move. Okay, so we'll talk about normal distribution more in our next video, but I just wanted to say that the normal distribution is a mirror image of itself, and it stems from the concept of central limit theorem. We'll talk about central limit theorem better in our next video. And then skewed data can be left or right skewed depending on where the tail of the column moves to. Let me just annotate and just say something briefly about this skewed data. Draw instead. Okay, so this is bad. Draw. Okay, so I'm going to use this. No. True. So this is a normal distribution. Then this is so bad. Then this is the right skewed data. And then there's the second one, I think is better. And this is the left skewed data. How do I undo this? Okay, so this is normal distribution. This is the right skewed data. As you can see, the tail is moving to the right. This is the left skewed data. The tail is moving to the left. So now let's say in that your the sample you got from your population, you see that these parts represent This part represents the rich persons. They are dragging the data to themselves. The Aliko Dangote, Otedola, Buhari, Atiku, they are dragging the meaning come towards them, giving you a false representation of the data. And these persons there, it could also be that the richest persons are also on the left, dragging the wherever the richest persons are, whether right or left, they'll be dragging the meaning towards themselves. But then this quotient curve or normal distribution is a true kind of give you a true representation of what is in that population. That is basically it. So we'll talk more about it in our next video. And I think so far you should be enjoying statistics right now. You should also be having it easy, a little bit easy when reading research papers and you're reading the descriptive part of it. You should understand what you're talking about. You should understand that in a variable, they're giving you, if the variable is parametric, there is a mean and standard deviation, and standard deviation tells you the spread of the data about that variable. It's giving you the mean as the best estimate, but it's also telling you that even though we have the mean as the best estimate, the range, that's the spread of the data, is between the best estimate minus the standard deviation and the best estimate plus the standard deviation, giving you the spread. And median is giving you the 50th percentile, telling you, let's say, like a 50th percentile telling you that 50% are above, 50% are below. If you have 60% in your score in the exams, you know that you're 60% better than everybody who took the test, and the 40% are better than you are. It also tells you, okay, the median, the interquartile range also gives you the spread around the median. Let me see if I can open a paper. Good. I don't think I'll see it here. Okay. So yeah, now showing you, this is the mean and standard deviation, how to report it. This is the median, showing you the 25th and the 75th percentile. It's showing you that the median glucose, like this, showing you 6.05 as the median for cases. The cases here are diabetics and the controls are non-diabetics, and glucose is the variable they're trying to measure. And it's showing you 6.05 as the median and 5.17 and 7.62 as the interquartile range. So these values in bracket is telling you the spread of the data. And so you can see, if you look closely, this 6.05 is contained in this spread. So it's kind of telling you that is this glucose content among the cases as a diabetic, are they closely together or they are farther apart? So that is basically it. Thank you for listening. And I know you might not get the concept more if you watch the video once. Why is this not showing? Is this showing now? Okay, so I'm sorry it didn't show earlier. So the 6.05 is the median glucose, while the 5.17 to 7.62 gives you the spread. And if you look closely, the 6.5 is contained within the spread, and the spread is trying to tell you this values in bracket is trying to tell you the spread of this data around the median. Are they close together? Are they far apart? Now, if you look at this for the superior oxide dismutase, you can see 40, then the median 91 and 185. You can see that they're kind of far apart when compared to the